Okay, box. What we'll do now is some characteristics. We'll open up the elevation data that we had, which is on our desktop. Samburu DM. Sorry, I always do it wrong. We can add from the layers. So we add layer, and we go into desktop. Samburu DM and let's because we do mathematical work on this. As you can see, we have our data set in here. Now, what we're going to do is look at train analysis. We're going to do some landform classification using PennocksLandformClassification. Now, ideally, this side here of the module would be where we've got the transparency that tells us what's what. Unfortunately, that hasn't been entered in at this stage. We can click on the create help entry, and you'll see why a little bit later on. This is how you put in that. When you Pennock classification, it comes out with 7 values for the type of terrain that you're in. However, nobody's telling you what they are. Okay, let's just say that that's that for the moment. Okay, and so we click and this. Now reopen, and we'll see we have this information here. Now, we want this analysis to be done on the UTM data that we imported, and we want the output file to be, well, let's create a subdirectory 1.4, and we'll call this Pennock 1.4. Okay, and save. Right. Okay. And but with the OK, everything's done. There we are. So what you can see now is basically a data set which has been calculated from the original digital elevation model. Each of the different cells has been classified into one of the 7 criterion, which are convergent foot slope, divergent foot slope, convergent shoulder, back slope, divergent back slope, level. Level. It's flat ground, and as you can see, the lakes are all coming out as level. If you want to find out exactly what those means, I would suggest putting a search in Google for landform, and hopefully of Wikipedia, or there we are. This is probably one. Yeah, this is talking about landform classification, and somewhere around there will be a in fact, this one will do quite nicely, I believe. Let's just open it here then. It just looks at the different types of landform units and how this algorithm works. And here we are. Here's Pennock. So we have a level area, we've got a foot slope, we've got a back slope, we've got a shoulder. And so essentially it's just categorizing the landscape based upon a number of criteria, based upon essentially just the DEM itself. So it's the number within DEM which I use to generate the classifications. Now there are a range of other algorithms that can be used to generate these kind of characteristics. So for example, you could identify a saddle or moraines in a landscape or specific types of ridge, and essentially that's the joy and the beauty of GIS. You can tailor the numerical side of it to exactly what your types of problem are. So we have a data set. Fantastic. So we now have a landform analysis. This, for example, could be utilised looking at, say, the distribution of some of your animal species. Are they on certain areas in the landscape which provide some good visibility? We can, for example, do visibility analysis. Again, it's something which a digital elevation model will do very nicely. Okay, thank you very much indeed.